In this section of the course, I'll be looking at streams, which were introduced in Java 8. When you think of a stream, you might be thinking of input and output, or I/O streams, like a buffered input stream or file output. That isn't the type of stream I'm talking about here. Oracle's Java documentation describes a stream as a sequence of elements supporting sequential and parallel aggregate operations. Another way of putting that is, a stream is a set of computational steps against a dataset that are chained together. In previous videos, I showed you method chaining with Lambda expressions by using convenience methods on predicates, functions, and consumers. I've also shown you that you can assign Lambda expressions to variables. This lets you pass around unexecuted code in the form of a variable to methods. This means the code in the variable is executed at a later date. Lazy execution, in other words. Streams are a mechanism for describing a whole series of processes before actually executing them. A stream is different from a collection in significant ways. The stream and the collection types were designed for different purposes. A collection is used to store and manage a series of elements in Java, providing direct access to the collection elements. As I've been showing you now for quite a few sections, you can use collections without knowing anything about streams to manipulate or query a set of data. In fact, all the examples I've shown you to date have done a lot of that, with iterators and a host of methods provided by the collection framework interfaces and classes. There's nothing you can do with a stream that you couldn't already do with a collection. However, a stream was designed to manage the processing of elements. This means that you, as a developer, don't have to design the processing code, just the process itself. Streams don't actually store elements. Instead, these elements are computed on demand from a data providing source. This source may be a collection, an I/O stream, or a database result. I'm going to pull up the Stream Interface's API document. First, this interface is generic and takes a collection of T, so a stream can process any type that's not a primitive. Java provides special streams for the primitive types as well, with intStream, doublestream, and longstream. If I select the Method tab on this page, there's a lot of methods on this interface, but what I want you to notice is what's not here. There's no add all contains get, put, or remove methods, the methods that are integral to the collection interface. This is because you're not going to be manipulating data elements individually in a stream. You'll be treating the stream as a unit or whole, oftentimes aggregating or reducing the data. Maybe you want to count the elements or group elements in the stream in some way. Another important difference is that streams are lazy, like Lambda expression variables. When you call many of the methods on a stream, execution may not immediately occur. Instead, you'll need to invoke a special operation on the stream like you would by calling a Lambda's functional method. This special operation is called a terminal operation. You might wonder, when would you want to use a stream instead of a collection? Streams are an exciting addition to Java because they provide several benefits. First, they make the code to process data uniform, concise and repeatable in ways that feel similar to a database's structured query language, or SQL. Second, when working with large collections, parallel streams will provide a performance advantage. I'm not going to talk about parallel streams just yet, because I'll have an entire section on concurrency later. There's plenty to cover on basic stream processing before diving into parallel streams. All of the code samples I've provided up to this point using collections will continue to be valuable for many use cases. Now though, it's time to talk about this new way of doing things using this additional functional programming feature. The combination of collections, Lambda expressions, and streams make it so much easier to produce the results you want with very little code, and the code is uniform, concise, and readable. Stream operations make heavy use of Lambda expressions and method references. If you haven't developed a strong degree of comfort with Lambda expressions, please take a few minutes to review that section again. It's especially important to be comfortable with the 4 commonly used category types: consumer, predicate, supplier, and function in the java.util.function package. Okay, let's get started.